Hi to students, it's Mr. Kaczynski with you. We're going to go through lesson 7.4's practice your skills exercises. This was over determining rates of change. Slope is a rate of change that we've been dealing with for some time. So we know that we're supposed to do change in y, so we could do 20 minus 7, that's the two y values, over change in x, 11 minus 2. Okay, so that ends up giving us 13 over 9. And I think I'll just leave that as an improper fraction. It is simplified, but that's our answer. 13 over 9 is the slope of a line that goes through those 2 points. All right, let's go again here. It really doesn't matter what order you do them in. I took the second one and subtracted the first, and the second x and subtracted the first, but as long as we go in the same order both times, it doesn't matter. So I could do 5 minus negative 4, that's my two y values, over negative 3 minus 6. 5 minus negative 4 is like 5 plus 4, so that's 9. And negative 3 minus 6 is negative 9, so our slope here is negative 1. 9 divided by negative 9 is negative 1. And the third one here. Well, I see right here that both the y values are 11, so I'm pretty sure that my slope is going to be 0 because there's no change going on there. Mathematically, it does look like this. So that ends up being 0 over 8, and 0 divided by 8 is 0, as opposed to if the 0 was on the bottom of this fraction, there was no change in your x values, that would not be a slope of 0, but that would be an undefined slope. We would call that an undefined slope. All right, the slope of a line is 2/3. If the point 6, 1 is on the line, name another point on the line. Okay, so here's what I would do, I think. 6, 1. I think the easiest way to look at this is, if our slope is 2/3, that means change in y over change in x. Y goes up 2 when x goes up 3. There's your 2/3, and that would get us to another point like 9. 6 plus 3 is 9, 3. So that's the point I would go to if I just had to name one other point. I could also go backwards 2 and backwards 3, and I would be at 3, negative 1. 3, negative 1 would be another point that would work on this. All right, for number 3, we are given this function y equals x squared minus 4. Find the average rate of change from x equals 1 to y equals 3. Well, I think mentally, I think I can figure out these y values pretty easy. When I plug 1 in here, 1 squared is 1, and 1 minus 4 is negative 3. So when x is 1, y is negative 3. And then when x is 3, you know what? Let's set it up like a ordered pair. Maybe that'll make more sense. When x is 1, y is negative 3. And then when x is 3, 3 squared is 9. 9 minus 4 is 5. So now that I've got those values, I can use them to figure out my average rate of change. So let's go change in y, negative 3 minus 5, over change in x, 1 minus 3. That would give us negative 8 over negative 2, which equals an average rate of change of 4. Let's graph this thing. All right, x squared, oops, let's try that again. How about x squared? Let's try that again. X squared minus 4. Graph it. Okay, so it's not a constant rate of change, but if we trace it and we look at 1, input of 1 gives us an output of negative 3. Input of 3 gives us an output of 5. That's what I calculated in my head. So if I drew what's called a secant line between those two yellow points right there, this would be the slope of that line, giving us the average rate of change over that interval. Let's do it again. All right. So we already know 3 gives us 5. We did that right here. What if we put 7 in? Okay, 7 squared is 49, and 49 minus 4 is 45. That's not going to show up on our graph as well. But then we just do the same thing again. I'm going to do 45 minus 5. That's my change in y. And then I'll do 7 minus 3. That's the change in x. That gives me 40 over 4, which equals 10. So my average rate of change over that interval is 10. Now, it's not true that x goes up or y goes up 10 every time x goes up 1. It's true that on average, when x goes up 1, y goes up 10. Write the equation of a secant line between these points. Okay, a secant line. Well, we already know when x is 1, y is -3. And we know that when x is 3, y is 5. So we already know that this slope right here is going to be true again. Okay, so it's the same one. So we already have the slope. We just have to figure out the y-intercept. Oh, you know what? I think I'm going to just do this. Why don't we just go, since the slope is 4, when I go down 1, y should go, I'll use green here. When I go down 1, y should go down 4, so that would be -7. All right, so I think I've got my equation here. It's going to be y equals 4 times x minus 7. And I think I'll graph that on top of this other one. So 4x minus 7, there you are, graph it. Kind of tough to see, but trace, when we put in 1, we get -3. When I press up and I go to the line, press 1, I also get -3. When I hit 3, I get an output of 5. And when I press up and I'm back on the parabola now, 3, 5 again. Okay, so this line goes through both of those points, and this parabola goes through both of those points. Let's do it again. I guess, how could we do this one? They're giving us the same values here, 3 and 7. Here's another way we can do it. We can go, let's use this point here, 3, 5. And I'm going to do 5 in for y. I know my slope is 10. Figured that out in part B. I'm going to put 3 in for x. And when I solve this equation, it'll give me b. Okay, so 10 times 3 is 30. And then subtract 25 from both sides, or subtract 30 from both sides. 5 minus 30 is -25. So my b value is -25, also known as my y-intercept. So now we can write the equation of the secant line. Y equals 10 times x minus 25. And I think we can graph this. Let's get rid of the other one. And let's go do 10x minus 25. Let's change our window a little bit because we want to get up to 745 here. So let's take it up to 50. Graph. There's our parabola. Here's our secant line. Okay, and you're going to see the 2 points where it crosses. Trace. 3, 5 is one of those points. Okay, that's one point that the line and the parabola meet, and the other one is 745. Yep, see, that's the other point where they meet right there. If I hit up, now I'm tracing the line. There's 745, and there's 3, 5. Okay. Akshay planted a garden and measured the height of one of his bean plants every day for a week. The data he collected are shown in the table. What's the rate of change from day 1 to day 7? Okay, I mean, just slope again. Okay, so day 7 8.4. Day 1, 3 was the height, so 7 minus 1. 8.4 minus 3.1, or minus 3. Can't believe I just used a calculator to do that. 5.4 over 6. So the average rate of change would be 0.9. 0.9. So over that 7 days, his plant was growing at a rate of 0.9 centimeters per day. What about from day 2 to day 5? Well, day 5, let's do a different color. Day 5 is 7.2 was the height of his plant, and day 2 was 4.2. So 7.2 minus 4.2 over the course of 3 days, right? I'm sorry, 5 minus 2. I got ahead of myself a little there. So that's 3 centimeters over 3 days. That's 1 centimeter per day. I think a label would probably be appropriate on these, right? Centimeter per day. And what is the average rate of change from day 5 to day 4? All right, so we're going to go 5 to 4. I mean, come on. I mean, we could do divided by 1, but I think we could just do 7.2 minus 6.1 is 1.1 centimeters per day. I'm not going to bother doing 5 minus 4 is 1, divided that by 1. It's still going to be 1.1. All right, now we're using a graph to figure out average rate of changes. They give us, over this interval from 0 to 4, estimate the average rate of change. Well, at 0, we're at -1. And at 4, oh boy, wait, 1, 2, 3, 4. It looks like we're at 5. So I'm going to do 5 minus -1. Those are my outputs over 4 minus 0. And that's going to give me 6 over 4, which is 3/2. A lot of people are probably going to put it in their calculator and say 1.5. Okay, whatever. Either one works just fine. Let's do it again here. From -2 to +2. So at -2, oh boy, what's our output there? I don't know, about 0.75 maybe. Let's write that down. 0.75, that's my guess. They're just telling us to estimate anyway. And at +2, well, looks like there's symmetry there, so it's 0.75 again. So from -2 to 2, it really doesn't matter. It's going to be 0 over -4. There was 0 change. Okay, even though a lot did happen from point to point, the average rate of change was 0. All right, and from -5 to 0. At -5, our output looks like it's 8. And at 0, we already know that the output is -2, so 8 minus -2 over -5 minus 0. So it's going to give me what? 10 over -5. The average rate of change is -2. So if I drew a line through those two blue points, the slope of that line would be -2. All right, that's all I've got for you. I've talked long enough. Hopefully you identified some mistakes. Let me or